Hello, everyone. A very good afternoon.
Good afternoon.
Good
Dear
I
afternoon.
think
authors,
it is morning over there, no? In Thailand. Hello?
yeah,
Yeah,
good afternoon to the ones in India and good morning to everyone from Thailand.
yeah. Same here. Good morning to everyone in Thailand and good afternoon to everyone in India.
Dear authors and invited guests, welcome to technical session 7F, 7D. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent Systems ICTIS 2025, held in Bangkok, Thailand. The ninth edition of this conference is being held in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held through Zoom on the 5th and 6th of April. I hope you will all have an enjoyable and knowledgeable session through the day. In this session, we have total of 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. And if you have any query or update, you can write it to me in the chat box. So before we start with the session, I'd like to introduce you all to our session chair. So Dr. Pradnya ma'am, she's an assistant professor at she's a professor at Symbiosis Institute of Management in Pune, India. Ma'am specializes in soft skills, e-learning, lecture organization development, and instructional development. Welcome to the session, ma'am.
Thank you. Thank you. Good morning to everyone in Thailand and good afternoon to everyone in India.
Yes.
Hello? Yeah.
Yes.
Yeah.
So moving on, we like to start with the presentations.
Yes, please. Who is the first
Before
presenter?
we start, I'll also like to introduce the second session chair, that is Dr. P. Aruna ma'am. Ma'am is Dr. P. Aruna ma'am is an assistant professor at Coimbatore Institute of Technology. She researches in programming languages, cloud computing, and virtualization. Welcome to the session, ma'am.
Thank you, ma'am. Thank you.
So moving on, we'd like to start with the presentation. I'd like to invite Sir in order to present their paper titled A Lightweight Real-Time Anomaly Detection System in Energy Consumption of Electrical Appliances in Smart Homes.
Okay, so I will share my screen now. Sorry, because there are some technical problems that I need to change my laptop to share the screen.
Sir, if you want, you can send me the PPT. I could share the screen.
Okay, I will share you
On the
and
chat.
Yeah. Okay, I send you in the chat box. Can you share it for me?
Yes, sir. Give me a moment. One second. Is my screen visible? Wait.
The PPT is not yet showing.
It is not visible.
Okay, wait, I'll do it again. Yeah. Is it visible now?
Okay.
Yes. But can it be enlarged a bit?
Yeah, let me try. I think this is the maximum.
Okay, fine. Please start. Thank you so
Yes.
much. Please start.
Okay, so today I will represent my team to talk about our paper. Our paper is lightweight real-time anomaly detection system in energy consumption of electrical appliance in smart home. And my name is Đức Anh, and I'm the speaker today. And first, I will talk about the outline. Can you change to the next slide for me?
Yeah, 1 second.
The outline
Yeah.
of my talk today. First, I will talk about the motivation why we decided to do this study. And secondly, I will talk about the overview of anomaly detection, about some research to date about this field. And third, I will talk about research objectives, the purpose of our research. And after that, I will talk about our proposed system architecture. And next, I talk about experimental results and conclusion and future work. First, talking about the motivation. Can you change to the next slide? The motivation is that the number of electrical and smart devices in home is rapidly increasingly. You can see that nowadays there are a lot of IoT devices and smart plugs, and these devices can collect real-time energy consumption data, which holds a great potential for monitoring and optimizing energy usage. And without anomaly detection system, abnormal consumption can lead to energy waste, higher bills, and potential equipment failures. That is our motivation. And next, we will talk about our about study to that. Could you change to the next slide? And the overview of anomaly detection. First, we need to understand what is the anomaly detection. And basically, anomaly detection is a process of identifying patterns in data that do not conform to expected behavior. And the purpose of anomaly detection is to identify abnormal patterns that may signal significant event requiring attention for further investigation. And there are three kinds of method for anomaly detection, three main types. The first one is statistical method. We assume that the data in a system follows specific statistical distribution, and then deviation from this distribution are flagged as anomalies. The second one is density-based method, like KNN, or we can detect points that are farther from their neighbors as potential anomalies. And the third kind of method for anomaly detection is using machine learning model. We can use some classification models like FVM or random forest to predict the label of data to be normal or anomalies. And we can use clustering method like DB-scan or K-means to detect the point data that anomaly. And in the next slide, I will talk about our approach. And can you turn to the next slide? And our research objective is to we need to research and develop a real-time system to detect abnormal energy usage in smart home. And the system has some constraints. It must be scalable. It must be very lightweight to be efficient, and it have to process a lot of events with low latency and high throughput. And this system will have the providers and homeowner to monitor and manage electricity more efficiently. And next, I will talk about the architecture of our system. The system is divided into many small components, and in each component we can use different technology. You can see that here we have smart plug to stimulate the device in home, and it will send the measurement to a server side through MQTT broker, and the event bridge will forward the message to message queues, and the purpose of message queue is for distributed process. This helps my system to scale really well in practice, and in the next slide I will describe each component.
I should do the next slide.
Yes, next slide, please.
Yeah.
Okay. As you can see here, my system is divided into different modules, and we leverage open source technologies for real-time anomaly detection in smart home. The first one is Smart Box Simulator. It will send the power UH data via app through MQTT protocol. And we have MT protocol. Here we use Mosquito as protocol to send message to server. And we also have event aggregator, which aggregates data in memory using Wolfram library from Google. And we also have the most important component is anomaly detector. It's use statistical median-based method, and it will send alert through via Telegram if it can detect anomalies. And in terms of visualizer, we use Grafana for real-time dashboard and monitoring. To serialize and deserialize data, we use Apache Script because it's more lightweight than JSON. Next slide, please. Now we'll talk about the anomaly detection components. It will receive energy data from every block, and it calculates median loss of each block and overall median loss across all blocks within a window size 1 hour. And a block is marked as abnormal if its median loss is higher than the system-wide median. And if the proportion of such abnormal blocks in a house change, like increase or decrease, an alert is triggered, and a message will send to user through Telegram immediately for immediate action. To implement this efficiently, we build a median container with leverage to multi-threads to update and retrieve median effectively in real time. Next slide, please. The setup of experimental system, we use two servers. The first one is virtual servers, and the second one is a physical server with high performance hardware. And the first one is just only used to install things like visualization tool or some website to manage the system. And the second server, we install data processing components, block simulation, cache database, MQTT broker, and etc. Next slide, please. In terms of data set, we use data sets from a grand challenge from a grand challenge, and it includes 4 billion measurements collected every second for 30 days from more than 2,000 smart blocks installed across 40 buildings in a city in Germany. And the data sets include some attributes like ID, unique identifier for measurement, timestamp, or value property and as an identifier for house and blocks. And next slide, please. Here is the user interface of our system. So people can monitor the lot average with different time window in the image. A graph with a time window 15 minutes. And as you can see in the right picture, notification will be sent when something when the anomaly detector component detects anomaly event. And next slide, please. In terms of experimental results, we focus on assessing the stability and processing speed and the reasonableness of detection methods. The reason why we don't focus on accuracy is because the data is not labeled. So we focus on the system stability, about the throughput, the latency, and processing speed. And as we benchmark with a 20 core system, we can handle up to more than 10,000 events per second. And as you can see in the left picture, it is the number of events sent per second by extracted smart box simulator, and we have a 20 cores, so it can handle up to 10,000 events per second, and the latency is quite good because it can handle the latency of processing events is less than 0.1 millisecond. And next slide, please. Here
Okay.
we compare with
Yeah, very interesting.
here we compare with for study denote A, B, C, D that solve the problem, detect anomalies in energy consumption using the same data set that we use. And at the table we can see that our proposed system can be comparable with other research. Maybe the hardware is different, but at the table we can see that our system can work well in practice because it has very good latency with different the number of hours. And next slide, please. In conclusion, we have researched and developed a complete system for real-time anomaly detection in smart homes, and it's not only perform well in laboratories environments, but also have high practical application potential. It can support intelligent energy management, cost optimization, and early warning about abnormal incidents. And our research open promising directions for energy solutions in context of increasingly popular IoT technology, especially the potential for integration with smart grid system. And in the future, we will enforce data encryption methods for both data in transit and at rest, particularly for data sent to and processed by external cloud devices, cloud service. Next slide, please. Okay, so next slide, please. So that's all my talk. And now, have anyone have any questions? Anyone have any question for me?
First of all, it's a very good presentation. And I would like to know which method you are using for anomaly detection.
I'm using a statistical anomaly detection because, as I said before, our system needs to have very low latency to work well in practice. So to detect that, we detect a plug anomaly if its load, if its energy UH is really high. So if a house have a lot of anomalous plugs, I will trigger an alert to tell people in that house about that.
Can you justify the reason? Because you have stated that many methods can be used for detecting the anomaly. So yeah.
Yeah, yeah. Could you move to the previous slide for me? As I described in the slide for anomaly detection. Yeah. Our methods is I will calculate the median loss of each plug and the overall median loss across all plugs within 1 hour sliding window.
Okay.
And a plug is marked as abnormal if its median loss is higher than that of system-wide median. I mean that the median of a plug is higher than the median of all plugs in all house. The plug is marked as abnormal, and the system will alert if a plug have a lot of if a house have a lot of plugs marked as abnormal.
Okay, I got it. Thank you.
Hello. Yeah. And do you plan to do any further research on this subject?
Yeah.
Yeah.
Actually, we have a lot of things to do further. Because the first one is that our approach at that time is very simple, and we also want to apply some more complicated anomaly detection methods like apply machine learning or the like. But in the future we will do research about that. And one important thing is that the system is now in laboratories, and what if we want to apply it in practice, we have to integrate it with electric system. Yeah. So there are things to do. Yeah.
Okay. Thank you so much.
Thank you for your presentation, sir. So
I
moving
think
on.
next person will be, I think, coming.
Yes, ma'am.
Or should
So
we
I'd like to-
invite questions from the other participants? I don't know.
No, ma'am, it's from the session generally.
Okay, fine. Okay, fine.
Yeah.
So the next participant, I think.
So I'd like to call Ms. Vemuri Sarvani for the paper titled AI-powered resume parsing and candidate scoring for efficient hiring workflows. Ma'am, please can you start with your presentation? Okay, I guess ma'am is not in the meeting. We can move on to the next presenter. I'd like to invite Shivani ma'am for her paper titled Auto Test, Automated MCQ Generation for Exam Preparation Using Agentic RAG. Ma'am, can you please start with your presentation?
Yeah, hi. Yeah, I'll share my screen.
Okay.
Hello?
Yes, ma'am.
Is my screen visible?
Yes, it's visible.
Hello? Yeah.
Yes.
Who is the next person? Hello?
Ma'am,
Yeah.
it is Shivani, ma'am, and she has presented the screen.
Okay, fine. Thank you.
Yeah. Good afternoon, everyone. I'm Shivani, and I also have one of my co-authors present today in the meeting, Samanvita. So this is our paper, Auto Test, and it is regarding how we can automate MCQ generation. So, this will be our agenda for today's presentation. So, introducing our paper. So, generally, MCQs are one of the most used method to assess any student's knowledge. Most of the competitive exams in India are MCQ related, and creating high quality MCQs manually by teachers or subject matter experts is really time consuming. And competitive exams like UPSC demand really high relevance and with regard to the current syllabus and accuracy. So our auto test, it makes use of GPT 3.5 Turbo. It's an LLM by OpenAI, and the method of agentic AI to automate it. It uses retrieval augmented generation for real-time validation, ensuring factual correctness and contextual relevance, which would be in relevance to every year's syllabus and their content that is required for the student to prepare for the exam. Yes, so our problem statement would be to eliminate the manual MCQ creation.
Excuse me. You are in the first slide, Ma.
Oh, um, it's not seen.
Ma'am, we could see your screen.
Um, do you see the slide saying problem statement?
No, I
No,
couldn't.
no. We could only see the main front screen. We can't see the other slides.
Okay.
Yes.
You see it now, research gap.
Yeah, now it's visible.
Okay, I guess when I go to present mode, it's not happening. Do I continue like this?
Yeah, it's fine.
Yeah. Uh, yeah, so we aim to automate and scale the process of manual MCQ creation so that it's more time effective. So coming to the research gap, the existing MCQ generations are based on traditional machine learning algorithms, which are not real time, and the sources are also not credible enough and are quite historical data. And due to this, they become highly static. So we try to eliminate this by using retrieval augmented generation, which will always make sure that the data we are extracting or retrieving is real time and is according to the present syllabus of that examination by making use of multi-agent orchestration with Crew AI, which allows us to create agents and give them tools and all the methodology so that we can connect each agent with each other in the required way so that they can interact with each other and give us our required results. So this is our architecture diagram. I'll give a brief overview of this. So first, the user can be either a student or any teacher who wants to generate MCQs. So they can upload the textbook to our system. So the first stage that it will pass through would be the pre-processing stage, where we will be extracting all the text and formatting it in a way that the next stages can make use of the data properly. So since it's a complete textbook that they can also upload, so we will be splitting the text chapter wise and extracting that content chapter wise and storing it. Uh, Along with it, we'll be doing the pre-processing of removing the stop words or the unwanted text in it. So then after pre-processing, we will be sending it to the summarization. So here, since the data can be really high, so we will be summarizing it into the most relevant content, whatever is required. And in our methodology, we have three main agents. One would be the topic identify agent, which would be identifying what topic it is related to, the content, and then based on that topic and the content, we will be passing it to the question generator agent, which will generate us questions, which will be the MCQs, and the question reviewer agent would be making sure the MCQs are semantically fine, or in in a more precise way, like the grammar and the format of the MCQs are up to the mark, and we are getting it as a JSON output, which would be used to store it in the vector store. These will be converted into the embeddings, and these embeddings will be again made use by RAG to provide us with an external link to the MCQ, so that they can make use of that as an external source to validate whatever answer we are providing. Yeah, so this is the methodology. The first one starts with text extraction and pre-processing, followed by extractive summarization, where we make use of BERT extractive summarizer, which again takes based on ranking and whatever sentence is more important or has more keywords is retained. And then the agent-based task allocation, as I mentioned, we have three agents. So each of it is allocated a task wherein the topic identifier will identify the topics, the question creator will generate the MCQs, and the reviewer will check for accuracy, clarity, and the quality of every question that is generated. Next would be the question generation, where here GPT 3.5 comes into action, where it will be used, like this is the model that we are using for generating all the MCQs. So one of the agent will be making use of GPT 3.5, and for checking whether the MCQs are relevant to the context, we have KNN matching, wherein while using RAG, we retrieve the top K chunks or embeddings that are most relevant to the MCQ and its answer. So the main purpose of RAG is to like validate whatever answer the LLM is generating. Like if it says MCQ has four options A, B, C, D, and we are saying the right answer is C. So we are making use of retrieval augmented generation so that it can go around the web and find a valid answer, or any website or a web page that can validate that yes, this is correct, and you can find extra information here. So this is our implementation. So this is the algorithm we have used to create the agent. This is the task generation and the review system. And yes, so coming to the results, so as you can see in UPSC, there are multiple formats of questions. One would be like a direct kind of a question wherein they have a question and four answers, and we have to select whatever the right answer is. And this is one of the questions generated by a system. And as you can see, we also have an extra external link so that the student or the user can visit it. And another one is the statement based. We also have true or false or reasoning and assertion type questions, wherein uh, there would be given a statement and they are supposed to find out if it's correct or not. Yes, so coming to a final discussion, so auto test is automating it using GPT and RAG, and it is always up to date, and it eliminates static data sets and also eliminates manual workload for educators, and it also supports all the diverse question types with UPSC format and ensures the quality with multi-agent review systems, and it is easily scalable to other systems like GRE, GATE, SAT or CET. And this is some of the future scope that we have identified for our project. So as I mentioned, it is highly adaptable to other formats. So we can also expand this to support multiple formats of the examination. And this can be also done in multi-language. Like now it only supports English. So we can also have Hindi, French, and other languages as required by the user. And it is, we can also have uh, like an adaptive and personalized MCQs, like we can have an analytics of how the user is performing in each. We can create like a quiz wherein we can make sure we keep track of each of the MCQ and the answer that the user is giving, if it's correct or not, and have an analytics board. And based on that analytics, we can again refine our MCQs like reinforcement learning. So
Sorry to interrupt, ma'am. 9 minutes are over. Can you please wrap up?
yes, I'm almost done. So based on the user performance, also we can adapt our MCQs. So these are some of the future scope. And yeah, some references. And yes, thank you for this opportunity. I would like to end my presentation here. So so if you guys have any questions.
Okay, ma. You're using generative for generation of questions. You're using GPT, isn't it?
Yes.
Can you justify why you're choosing this?
Okay, so the GPT 3.5, that was a model released by OpenAI. So it was really good with text generation. I agree, every LLM is good with this, but some part of the GPT was also specifically fine-tuned with some of the big data sets, like MCQ data sets, so that it can also generate accurate MCQ. So this was one of the reasons we uh, made use of GPT 3.5. And also, one more thing is that it should also be open source for everyone. So, this is freely available. So, the user will also not have any problem about like having a subscription or going for a paid version.
You talked about your exams, also using it for exams. But what can be the possible pitfalls over there for the users or for exams?
Uh, I'm sorry, can you repeat it?
No, I said what could be the possible pitfalls if you are using this thing that you are proposing for exams, important exams that you mentioned.
Yes. So for like different exams, like even in the question, uh, the generator one, here we have given the create question task wherein it is fine-tuned, or more importantly, like hard-coded to that exam. So if I want for UPSC, I can have these kind of question types: direct statement and assertion. If the user wants it for their university exams, they can also they can change this module maybe that we will be providing them, uh, so that it also suits for their personal use case. I hope I got it right.
No, not exactly. I was actually asking what would be the possible obstacles or shortcomings if you use it.
Okay, okay. Yeah.
That's what I am getting at.
Obstacles. Actually, this one of it that we tried to eliminate the obstacles. Like the most important when we come to MCQ generation is the ML based algorithms that are completely rule based, and they always work on historical data sets. So to eliminate this, we have made use of like an LLM that is already very good at this task. And another one can be maybe while scaling it, we might have a memory constraint or a space constraint. And if the user wants for a better LLM, then they will have to go for a paid version, and most of the users don't prefer a paid version.
Okay, fine. So if it is a paid version, then there are less issues.
When it comes to MCQs, comparatively all work good, like all the LLMs that are present right now. So
Okay, thank you.
yeah,
Thank you. Thank you.
yeah, thank you.
Thank you so much for the presentation, ma'am.
Thank you. It was a good presentation. Are you going in for patent?
Uh, we have not yet thought about this. So if the team is interested, I would love to.
All the best.
Thank you so much.
Moving on next, I'd like to call Mr. Van Ho for the paper titled Enhanced Real-Time Surveillance with LRCN, Automating Suspicious Activity Detection for Scalable Security Solutions in Vietnam. So please can you start with your presentation? Sir, can you please start with your presentation?
Is he there or he is not connected?
Yes, sir, is in the meeting. Okay. Meanwhile, we can go to the next presentation. Okay, sir has started the presentation.
Okay.
Sir, are you facing any connectivity issues? If you're facing it, then we can either move on to the next presentation or else I can present the PPT for you. Let's move on to the next presentation. I'd like to call Mr. Nam V for the paper titled IoT-based healthcare management and support system for diagnosis and treatment. So please can you start with the presentation?
Yes, ma'am. Let me see my screen. Can you hear me?
Yes, sir.
Okay. Can you see my screen?
Yes, sir.
Okay, great. Okay, I will start now. Good afternoon, everyone. I'm excited to be presenting today at ICTIS 2025 with a project, IoT-based healthcare management and support system for diagnosis and treatment. My name is Nguyễn Văn Nam from FPT University, Hanoi. Our presentation will have 4 parts: introduction, system detail, result and discussion, and conclusion future work. So let's go into the introduction. As we know, IoT is transforming healthcare, making medical service smarter, faster, and more focused on patients. So with smart wearable device, doctor can monitor patient in real time, detect health issues early, and provide timely treatment. But a good IoT healthcare system is more than just smart device. We need to find the right balance between security, scalability, and smooth data management. So everything from secure system design, flexible data storage, to well-linked hardware and software need to work together. So our project will achieve that objective by integrating multiple technology. First is SaaS, which is software as a service to streamline daily operations. Then a data warehouse, which store and process key information, including real data and patient report pharmacy outcome. And finally, we use RFID technology to help identify patients when they retrieve their medication. And this approach will make data more accessible, improve operational efficiency, so leading to higher quality healthcare. So let's moving to the system detail. I would like to talk about overall architecture first. The figures here show the deployment architecture of the healthcare system that having three main components: hospital network, the system center, and the national data center. From the lab, each hospital will run its own network having admin, doctor PC, and hardware device for patient interaction. This network connects securely to the system center through Cloudflare side-to-side VPN, ensuring encrypted data transmission. Next, the system center serves as the core hub. It hosts a Tomcat web server that manages real-time interaction via web applications and APIs. It integrates key database, including three main ones, which is pharmacy DB, residential DB, and EHR DB, or electronic health record base. This allows healthcare providers to access essential patient and medication data. And we also integrate Apache Airflow that orchestrates ETL process to keep data synchronized across the system. The drug bank API continuously updates the pharmacy database with medication details, drug interactions, and dosage guidelines. Then the residential database also receives regular updates with demographic and patient data that can support historical health analysis. So to set up a side-to-side VPN connection, we have to use various Cloudflare services. First, Cloudflare's Zero Trust enforce identity-based access control by requiring users to authenticate via Google Identity Service before accessing the private network. Next, Cloudflare Access form an outbound-only tunnel, Cloudflare Access Tunnel Server that will eliminate the need for open inbound ports, reducing security risk. And finally, the Cloudflare Access Tunnel Server will securely communicate with the private network. All data transmitted through this tunnel encrypted to ensure confidentiality and security. The next one will be the data synchronization workflow. And as you see here, there are three main tasks for each data pipeline. First, system will retrieve the latest data from external source, such as drug bank APIs, and store it in an Excel format for flexibility and compatibility. Then the system synchronizes the new data with existing database records using the SCD Thai approach. And we also use commit and rollback statement that will prevent partial updates in case of a connection failure. Once synchronization is complete, Apache Airflow will send a notification to the development team for review. If the process fails, no confirmation email is sent. It will allow quick detection and resolution of issues. And finally, the hardware of the system. We propose a hardware architecture that integrates an RFID write block in the admission office and a read block in the treatment rooms. The write block registers a patient RFID card with their admission data and store it on the card. The read block, located near the drug cabinets in the treatment room, will enable quick retrieval of patient data by scanning through the RFID card. So this design uses ESP32, which has built-in Wi-Fi and a real-time clock for accurate timekeeping. So it eliminates the need for extra components. It also supports real-time data transfer via API, and also a TFT display is also included that can provide multi-line text and multi-language support to enhance accessibility and reduce errors. So I will share about the result of the system. The first one is hardware components. The device is smart and portable with all the electrical parts inside a box that have a USB port for easy connection to a computer. It uses a standard communication protocol and can be monitored using the Hercules utility as you see in the screen. So to use this, the RFID card is placed on the surface of the device. The admission ID is entered via the dialog, and the data then written to the card with a confirmation from both the software and lines on the device. The reading device is also placed in a box next to the pill cabinet. When the RFID card is placed on the reader, a buzzer sounds and a loading info message shows up on the display before showing the medication instructions. So the buzzer also reminds patients of medication times based on the hospital schedule, helping them follow the treatment. This system will work well for patients who are familiar with the device and can read the instruction. And finally, I talk about the data synchronization efficiency with Gantt graph analysis. The graph sequence starts with the raw data from DrugBank API tasks, which fetch data from the DrugBank public API from Vietnam, retrieving about 10,200 records in about 2 minutes. However, for larger datasets, Excel is impractical due to its row limit and processing overhead. So we propose to use Parquet, a columnar storage format, which enhance data handling with improved compression, storage efficiency, and performance. The next task, STD6 Syn to Medicines, will synchronize the retrieved data to medicine database, and it takes about 7 minutes. Each record update, which involve a sort delete and insert, have take an average 58.7 milliseconds per record. While this data seems reasonable, the linear update process can create possible overhead. So to improve efficiency, strategy has been discussed, like updates and proper indexing. And the final task, send email notification, will send a notification upon task completion and will take less than 1 minute. It demonstrates minimal processing time. So to conclude, the project has successfully integrated RFID technology with web application to enhance medication adherence and data synchronization in healthcare. The use of compact RFID reading and writing device has significantly improved efficiency for hospital staff and have patients manage their medication regimens. The user-friendly web application also allows easy access to critical information, while the reliable synchronization process demonstrates the system effectiveness in data management and operational performance. Although challenges such as manual data entry and synchronization efficiency with larger datasets have been identified, there are clear opportunities to improve them. And in addition, since the system collects real-time patient data, integrating predictive analytics or machine learning models for early diagnosis or anomaly detection could be a promising consideration in the future development. So thank you for your attention to the presentation. Now I would like to open the floor for any questions you may have regarding.
See, in the first slide, you have mentioned that you are using SA, software as a service.
Yes.
Can you explain it? Which software you are using from the cloud?
Yes, it's like a software service is come from the company that will dedicate to build a software service for a target purpose, like a Cloudflare is a famous security company that provide reliable security solution for protecting organization network.
Okay.
Thank you.
Thank you so much for the presentation, sir.
Okay.
Moving on next, I'd like to call Van Ho, sir, for his presentation.
Can you hear me?
Yes, sir.
Okay. Yeah, one moment, please. Good afternoon, everyone. So, my name is Van Ho, a lecturer of FPT Greenwich University, Vietnam. My quarters is FEMA and Hai Hong. Today, I will present the topic, Enhanced Real-Time Surveillance with LRCN, Automating Suspicious Activity Detections for Scalable Security Solution in Vietnam. In Vietnam, you know that the rising crime rate puts pressure on the traditional surveillance system, which rely on human monitoring and are inefficient. So this study developed an automatic surveillance system using IRCN, combining CNNs and LSTN to detect suspicious activity in real time. This system achieves over 85% accuracies, is easy to integrate, and is suitable for residential, commercial, and public security. For related work, human activity recognition is crucial for real-time surveillance, but traditional methods struggle with subtle behaviors. LRCNs integrates CNNs and LSTN, enhancing accuracies and reducing false alarm compared to previous model. This study proposes cost-effective, scalable surveillance solutions ideal for resource-limited region like Vietnam. We propose LRCN's model for detecting suspicious activity in video surveillance, combining CNNs for spatial feature extraction and LSTM for temporal analysis. In figure 1, you see that it illustrates how CNN detects shape and edges, while LSTN track behavioral changes over time, enabling detection of theft or loitering. This slide presents the detailed structures of the RCN's model in table 1, in which CNN extracts spatial feature with max normalizations and max pooling, optimizing efficiency and reducing overfitting. LSTN analyze temporal dependencies, while the dense or submask layer classify behaviors as normal or suspicious. Video data preprocessing is essential to enhance model performance. Data preprocessing ensure consistencies and efficiencies during the training and inference phases of the LRCN's model. In step frame extractions, it split data video into frame at 30 frames per second to capture temporal details. In step frame resizing, it resizes frame to 64 by 64 pixels for optimized processing. In step normalizations, it scales pixel values to the 0-1 range. In step frame sequences, it's group 30 frames to enable temporal analysis using LSTM. Figure 2 shows the processing pipeline, standardizing input data for more accurate predictions. The LICM model is trained on the KTH actions and UTF RAM datasets, which includes the both normal and suspicious activity. For transit split, the dataset is split into 75% training, 25% testing to prevent overfitting. For optimizations, the models uses Adam optimizers and categorical cross entropy to measure prediction accuracy. For batch size and e-box, the model is trained with batch size of 4 up to 50 e-box. Is with the early stopping if accuracy stabilized. Figure 3 show accuracies and loss curves with the achieving over 85% accuracy, proving its effectiveness in real-world surveillance. This surveillance system consists of 3 main steps. In the first step, video processing, it splits the CCTV footage into frames and normalizing data. In second step, LRCN's model processing, CNNs extract spatial pictures, while LSTNs analyze temporal sequences to detect suspicious behaviors like theft. In the first step, action classifications is identify actions such as lifting, jogging, climbing, enabling real-time alerts. This system operates quickly and efficiently, ensuring timely response to security threat. This system is evaluated on the 4 datasets simulating real-world surveillance. Datasets DCS ASS includes 896 lifting videos, 2,048 stealing videos. Datasets prime include 35 lifting, 30 stealing videos supporting early RAM detection. Dataset shoplifting includes 130 videos simulating retail theft. Datasets walking includes 10 videos helping distinguish normal from suspicious behavior. For efficiency, the models were trained using TensorFlow 2.3 OpenCV with the 100 e-box, base size of 4, and GPU, and NVIDIA GTS 1080 Ti.
Excuse me, sir, just a gentle reminder that around 9 minutes are over. Can you please wrap up?
All right, okay, just we almost finishes, okay. The experiment result confirmed that the LRCN's model perform effectively on real-world scenario. For accuracies, the other model achieved 87%. For the activity detection, the figure 5 illustrates the model ability to detect suspicious behavior in the surveillance footage, such as motorbike theft and walking, demonstrating its practical effectiveness. The experiment also confirmed that the LRCN model is stable and effective in the real scenario. Okay. In the figure 6 demonstrate the model ability to detect motorbike theft in surveillance footage, proving its usefulness in high-stakes security situation. Yeah, and this is the evaluation result confirmed that the LRCNs achieved a high accuracy and versatility. Table 3 validate the model strong performance across various activity, and figure 7 present the confusion metric showing a high accuracy in detecting lifting, stealing, and walking. Still, some misclassification remain, such as lifting mistaken for stealing and walking, stealing confused with lifting and walking, walking slightly confused with lifting and stealing. Compared to VGG 19 and RISNES 50, LRCN's model achieved the highest accuracy with the 87% due to its temporal modeling capability. For the discussions and error analysis, LRCN's model still have some limitations. False positive, negative, misclassify fast movements and suspicious and misses detections in low light condition. Occlusions and poor alignment affect detection accuracies. Ambiguous behavior, actions like adjusting clothing or carrying bags may be misclassified. To enhance performance, we propose solution. Attention mechanism to enhance focus on the spatial temporal feature, data augmentation with the low light and occlusion scenario, anomaly detection to reduce misclassification error. For conclusion, this study developed the intelligent surveillance system using LRCNs, integrating CNNs and LSTN to detect suspicious activity, improving accuracy, reducing manual monitoring, optimize costs, making it especially suitable for resource-limited region like Vietnam. For the future enhancement, we integrate enhanced deep learning models and assembly learning, applying ML Ops, IoT, and facial recognition to enhance detection capability, expanding into healthcare, education, and retail, leveraging AI and IoT for further potential. This is all for our presentations. If you have any question, please let me know. Thank you so much for your listening. You have any question?
So what's the size of the data set you have taken? Hello?
Yeah, okay, one moment. So it seems that I lost the, okay, one moment. Okay. Can you see my screen? Okay. Yeah, can you repeat your question again, madam?
So actually you're mentioning the data sets you are using.
Yeah.
So can you tell me what is the size of the data set? Are you taking only the videos or images also?
Yeah, so the size I can see that here. One moment. We have only the I cannot remember the yeah. So we have the This is the
Yes.
four data sets, right? For evaluation, and we have the training on the KTH actions and UCF-RAM. And the size here is we have the video, number of video on that, but the actual volume, you mean? I can't remember. Yeah, this is the
So I got it, sir. Got it.
okay. Thank you.
Okay.
Thank you for the presentation, sir. Moving on next, I'd like to call Miss Amla Sibi for the paper titled Managing Retail Credit Default Risk Using Artificial Intelligence and Machine Learning, Ethical Consideration and Challenges. Ma'am, can you please start with your presentation? I believe ma'am is not in the meeting. So we can move on to the next presentation. I'd like to call Sir for the paper titled PCA-based classification of traditional Japanese stencil images. Can you please start with your presentation?
Okay, I am shared my slide.
Yes, sir.
Can I see the slide?
Yes, sir.
Okay. Okay. Good evening. I'm Kohei Mafuji. Today, I would like to talk about classification of traditional Japanese stencil images using PCA. First, let me explain the background of the study. My lab is working on Isekatagami classification using machine learning. I will now explain the characteristic of Isekatagami. Isekatagami consists of the Z and G. Z is the area surrounded by blue in the image on the right. Isekatagami images are characterized by the high level of abstraction of the patterns depicted as in the upper right images, and by the inclusion of multiple patterns in a single katagami as in the lower right image. In addition, large datasets of katagami are protected by copyright and cannot be uploaded to the internet. The Ritsumeikan University Art Research Center has approximately 18,000 katagami image data sets, but the classification is done manually, and only about 860 images, or less than 5%, have been classified. Due to the various factors mentioned above, it is difficult to classify using existing methods, and methods other than deep learning, etc. are needed. This study is the classification of small-scale copyright-free Isekatagami image datasets that can be purchased as books. The classification problem is to classify a simple repeating pattern with only ground, as in the upper right group of images, or a mixture of a figure and a ground, as in the lower right group of images. In the past, we have conducted additional experiments with similar classification criteria and with the EMD classification method considering frequency components, which is a prior study. EMD is a method for finding the distance between two features, and this method uses EMD as the distance function used to compare images. Although this method was about 80% accurate, it took a long time to execute. In this study, we propose a PCA-based classification method that outperforms EMD-based methods. Specifically, we aim to classify the two types of images mentioned above by using PCA, which is used for pattern recognition of images in order to improve the accuracy and F measure of the EMD-based method and to reduce the execution time. Detailed explanation of the method using EMD is omitted because it is a past study and different from the method proposed in this study. I will now explain the PCA used in this study. PCA is a method for dimensionality reduction while preserving the characteristic of the original data by expressing the data using a combination of orthogonal bases called principal components. The first, second, and third principal components are followed by the second and subsequent principal components, which are axes orthogonal to the first principal component. They are also ordered in descending order by what is called the contribution ratio, which is the percentage of the sum of all principal components. And the objective is to analyze the data and identify the axes that best represent the variation in the data and concisely represent the data. This is an illustration of PCA in two variables. Principal component analyzes set a new axis for a given data set in the direction that best represents the variability of the data, i.e. the direction that maximizes the variance of the data. Set the first principal component as a new axis in the direction of greatest data variability as shown in the figure on the right. Let's move on to the explanation of the proposed method. PCA is intended for dimensionality reduction, and classification is expected to be difficult simply by using PCA itself for image classification. However, as mentioned earlier, PCA is used for pattern recognition, so it is possible to recognize regular patterns on stencil. Therefore, we consider that the contribution ratio value will be higher when the regular pattern of the pattern and the patch size when the image is patched match. We classify images that contain regular patterns by varying the patch size and seeing how the contribution ratio changes. The following is an explanation of the specific procedure. The proposed method consists of the 4 steps shown in the slide. First, to change the patch size,
Excuse me,
increment.
sir. Sorry to interrupt. Around 9 minutes are over. Can you please wrap up?
Okay. First, to change the patch size incrementally, set the start patch size and the end patch size. Next, divide the pattern into patch size pieces. The patch is divided with the patch size determined as shown in the figure on the slide. In this case, Only the patches obtained by discarding the right and bottom slices are of interest. In the third step, the PCA is calculated for each patch size and the contribution ratio is calculated. Perform PCA on images segmented by a given patch size and records the contribution ratio and the patch size and at that time. The height of the patch size is then left unchanged, and the width is increased by the one step to be the patch size for the next one. If the maximum width is reached, the next patch size will be the one with the height increased by one step, and the width updated to the minimum value. Uh, どうしようかな。ここまで。見て。In addition to the proposed method, we have also included experimental results of a method using EMD with frequency components as described above, and a method using only the first principal components of PCA. The parameters were set as shown in the slide. And this is a table of experimental results. The values of the accuracy, precision recall, and F measure for each method are listed for each of the 40 pattern images. The proposed method successfully outperformed EMD-based methods in terms of recall and F measure. Conclusion and future task will be described. We used PCA to classify Isekatagami. The PCA-based precision was lower than the EMD-based rate, but other values were better. In the future, we aim to extend our approach beyond binary classification by extracting features for each image motif, enabling more detailed classification methods. Thank you for listening.
Sir, did you fix the size of the patch?
Sorry, can I? Sorry.
In the 16th slide, you are mentioning the size of the patch is fixed.
Sorry, I'm not good at listening English, so どうしよう。Translation. So repeat after me. Oh, sorry.
Okay, sir. Do you have any future plan for extending this research?
Oh, sorry. Yes. Sorry, I'd like to send you a question chat. I'm not good at listening, sorry.
Do you have any future plans? That means future extension.
Future plans. Okay.
Yeah.
Oh,
For
sorry.
this same project.
Thank you.
Okay, sir. Good work. Ma'am Richa, ma'am, shall we go to the next?
Yeah,
Yes.
sir was answering the question.
Okay, ma'am.
Okay, sorry. Uh,
Thank you.
Thank you, Sarah. Sorry.
Thank you so much. Moving on next, I'd like to call Mr. Pranav sir for the paper titled Smart Mining Helmet and Integrating AI for Enhanced Safety and Efficiency in Underground Mining. Sir, can you please start with your presentation? I guess sir is not in the meeting. So moving on next, I'd like to call Amelia ma'am for the paper titled Students' Expectation and Challenges in Databases and Web Programming. Ma'am, are you in the meet? Can you please start with your presentation? Ma'am isn't in the meeting. I'd like to call Miss Amla Sibi ma'am. Ma'am, are you in the meeting? Can you please start with your presentation? Amla ma'am. Also one last call for Vemuri Shavni ma'am.
Yes, ma'am. Good morning, ma'am. Good morning, sir. My name is Shravani. I'm pursuing fourth year of BTech from Shiveshna Engineering College for Women in Information Technology in Andhra Pradesh, India. So, in my project name, which is AI Powered Resume Passing and Candidate Scoring for Efficient Hiring Workflows. Uh, about my project in today's hiring process, one of the biggest challenges is that time and effort it takes to manually and go through the resumes. Recruiters often miss out on good candidates.
Ma'am, can you share the presentation?
Yeah, ma'am. My project name, which is AI powered resume passing and candidate scoring for efficient hiring workflows. In this project, nowadays in today's hiring process, one of the biggest challenge is the time and effort it takes to manually for throwing the resumes. Recruiters may be often checking for the good candidates because of human errors, and candidates also struggle to match their resumes to job description. Our main motto of this project helps to building an AI powered resume that automatically reads and understands. It understands the candidates improving by suggesting some of the keywords and missing keywords and like generating potentials interview questions also. We used OCR for character recognition to read resumes in different formats and NLP techniques to extract the informations and important modules and important details like skills, education, and work experience. Here we applied some of the algorithms like embedding to match candidates for the job roles and more accurately. Here we also created a ranking system that scores each candidate based on how will they fit their job, for how they match their job description and all. So here we use a data set like here we use data set with resumes from different formats and different colleges, different industries. Here and the result were really like a F1 score. Here is our proposed methodology for my project. After the data collection, we here data processing by using OCR and method recognition. And after that, model selection is based on the algorithms. Here we use NLP algorithm for the extracting the information. After that, we created a testing method. Here, testing is like it is used for testing the keywords like is there any missing keywords, or is there any uh, like example of A and the it deletes that type of data, and it actually takes only important data details like what is the job description, what is the current skills they have, that type of first it tests, and then it create a model uh, like resume formats gives a score like you have to improve your experience, you are at a fresher level, it gives like that. Here we for developing the application we use a Streamlit application, Streamlit library we use for uh, uh, for Streamlit we are main focus of to improve this module because of their fast and fast and applicable environment. So we use a Streamlit library, and we are also provide some inputs like job description and output with the model accuracy. And then we already said that it resume passing like a PDF format by using the OCR recognition, and then it extracts the information based on their skill matching and their job roles. Here, the performance metrics like by using this project, our precision is like 90%, and F1 score is a F1 score is 89%. Comparing to other models and other methods, it is very easy to use, and it provides us some like resume tips, and it provides a score, and also accuracy of information extraction is also 4.6 out of 5. Skill matching, it gives a 4.3 out of 5. Here is our results of my project. It gives some resume tips and ideas, and it gives names, and then it provides some recommendations, skills and courses and certificates. Here it provides some recommendation skills and recommendation what their current skills and what needed to improve their current recommended skills, and it provides also interview tips, and it provides also resume writing tips also. Here what we achieved is a faster, smarter, and more reliable way to screen resumes and shortlist candidates. For we are looking ahead, we are planning to add predictive scoring and make it even more helpful to the industries and more tailored to the industries. In short, our project makes that hiring process easier for the recruiters and more transparent and helpful for the job seekers or the job needers. Our achievements like in our project is we get an high accuracy uh, before other projects also. This is our references.
Ma'am, in one of your slide, you have mentioned, that means you have compared your method with some other methods. and they're mentioning that your method is good while compared with the existing. How did you measure it, ma'am?
Ma'am,
No, not
your
this one. Previous, and this one.
yeah, ma'am. We are using deep learning based we are comparing with the deep learning previous method. It does not gives an accuracy of the that much result of precision and recalling. So here we are using comparating to the deep learning, we are using here NLP. By using this NLP, it gives a extracting the details like skill matching and job description. Based on that, it gives results of the high accuracy, and it gives course recommendation accurately based on their job description.
Okay, ma'am.
Can I run my code, ma'am?
No, ma'am, no need.
Okay. Thank you for the presentation, ma'am. I'd like to call Mr. Kisalya Chakravarti for the paper titled Wave Vector Compensation in Confinement of Light. Sir, can you please start with your presentation?
Good afternoon, ma'am. Just trying to share my. Madam, can you see my slides, madam?
No, sir.
No, your slides are not visible.
Okay, madam.
We are just getting to see some screen of flowers.
Okay, madam. Now is it visible, madam?
No.
Sir, do you want, if you want, you can send me the PDF, PPT. I could present it.
Okay, madam. PPT to madam to.
In the chat, in the Zoom chat.
That I have already given, madam. I cannot open.
Sorry,
The chat
sir.
I have. Can you see in the chat I have already given?
No, I cannot see. So can you resend it?
Madam, now it is not okay, madam.
I think in the meantime he should start because we are short of time. What do you say, Aruna ma'am? Hello?
Yes, ma'am. Yes, ma'am.
Yeah, so please start in the meantime because we are
Sir
short of
left
time
the
and
meeting
please
actually.
adhere to the time frame.
Richa, ma'am, how many papers we have completed presentation?
This was the last one.
Oh, okay, ma'am.
I don't know.
Those who could not come, are they joining later on because they might not be aware of the difference in the time frame? Maybe because of that.
No, we're almost done with everyone. Sir is the last presenter.
Okay.
So, can you start with your presentation?
Yes, please start the presentation.
Sir, if you cannot present the PPT, then you can at least start like presenting it without the PPT. Meanwhile, you can send me in the chat.
Madam, can you show me the first page? Just
Please start talking.
Sir, I don't have your PPT. I cannot present it, right?
okay, madam. My topic of discussion is the wave vector compensation in the advancement of light in any substrate. So what I have done is, so light cannot be stored inside any substrate because of the dispersion property. If you try to store the light, it will disperse out, and you cannot get the light in front of in the form of pulse or any other means inside any optical fiber or substrate. So our main objective in this research is to how we can store the light inside inside any substrate like optical fiber or photonic crystal fiber. So that was done by one Japanese scientist. His name was Tohoiko Baba. And after that, but what he has done is he can able to slow the light, and he cannot completely stop the light, but he has stopped slowed the light to some extent, and that was a very good achievement. Now, after the invent of metamaterial, that means it has a negative refractive index. Meta means it is a man-made. Anything which is man-made, any material is called metamaterial. So in the negative refractive index material is also called a metamaterial because the light will flow in the opposite direction. Means the refraction index is like that. It has a negative refractive index, so the light will go in the opposite direction. So what our work is, if I put the light inside a charged kind of photonic crystal fiber. Photonic crystal fiber is nothing but it is the periodic arrangement of photonic crystals inside a substrate or inside a optical fiber. So we can easily switch the light in any direction. If I have a gap, that means lattice gap or a line gap, so the light will be follow or advance in that line gap. So what is the advantage? We cannot, if I give a sharp turn, suppose a L type of turn in that photonic crystal fiber, so light will not get the bending loss as we have seen in the case of optical fiber, and the light will be very good, switching will be done in the light. So we have used the optical photonic crystal fiber with a chirp type of arrangement, both in position and as well as in shape. What is the chart? That is a photonic crystal fiber. The shape of the photonic crystal fiber is not uniform or constant. So it is gradually the shape of the crystal is increasing. So what it will do? It will when the light is flowing through the fiber, it tries to slow down the light because there is a there is a wave vector compensation. So it will try to push the light in the opposite direction, but the light still passes through it, and the light is slowed down. Now, if I use this photonic crystal fiber, the metamaterial photonic crystal fiber, that means which is having the negative refractive index. So the wave vector direction and the direction of the refractive index means the wave vector is originated from the negative refractive index by photonic crystals. They will compensate each other, and this phenomena is called wave vector compensation. And if I do the good engineering with a sharp kind of photonic crystal fiber and with the metamaterial that is having the negative refractive index, so we are able to confine a pulse for very long time, or theoretically for an infinite time. So by this we can completely stop a light pulse or light inside any substrate. That is my work, madam. Unfortunately, I will send you my slide afterwards to you. That is called wave vector compensation, and we have published on this paper to Journal of Optics in Institute of Physics publication. And also the position, the chart position we have already published, and the chart in shape of photonic crystal we have just given to this conference. That is our work, madam. Thank you, madam.
Okay, sir.
Yes, ma'am. Ma'am, you would like to ask something?
No, no, ma'am.
No, even I would.
Ma'am, one last presentation by Amla, ma'am, because she wasn't able to present it earlier.
Yes.
Yeah, ma'am, please can you start with your presentation?
For me, ma'am.
Sorry?
Who's going to present?
Amla Sibi, ma'am.
Okay.
Hello, I am trying to do my screen sharing. Just give me a minute. I am unable to share my
It
presentation.
is all right. You can start talking about your research.
So, good afternoon, everyone. My topic, which I'll be presenting today, is managing retail credit default risk using artificial intelligence and machine learning, ethical considerations and challenges. So, basically, over here, I'm trying to explore the different methodologies through which the credit risk can be managed with the help of artificial intelligence and machine learning. I hope I am audible.
Ma'am,
Hello?
can you send the PPT in the chat if it is possible?
All right.
Madam, I have sent the PPT. Have you got it, madam? I've tried.
Yeah, sir, you sent it right now. So now I got it after the presentation.
No, it is all right. The person who is presenting now can, if possible, try to post it on chat. In the meantime, she can continue, I think.
Yes, I have posted it. Have you received it?
One second. Yeah. Give me a moment. I'll present it for you. Yeah.
Okay, so I have studied a little bit about the existing models and designs, such as gradient boosting, bagging neural network, support vector machines, random forest, and logistic regression. So these are the models which are existing in this particular area for managing credit default risk using AI and ML. And apart from that, from the studies, I have identified that there is a model exposure. So I have from the studies, I have created a model exposure in.
Ma'am, I've presented your screen. Which slide should I go to?
Good.
That's fine.
Yeah. Can you just go forward? You can go forward.
Yeah.
Go forward. Next one.
10 minutes.
Yeah.
Yeah.
Next.
Okay.
Next.
Take it.
Next one, ma'am. Next one. Yeah. So in the particular model, phase 1 is data curation and pre-processing. Phase 2 is data tagging. Phase 3 is data training and validation. Fourth phase is data testing. Fifth phase is credit default prediction and labeling. And sixth is model assessment and review. So these are the 6 phases through which the credit risk prediction models work. Ma'am, can you go to the next one? So as per the labeling, the defaulters can be labeled as responsible borrowers, which has low risk and high reliability, then impulsive borrowers, which are having low to moderate risk, then the distressed borrowers who has been identified as moderate to high risk, and the last one is negligent borrowers who has critical risk and low reliability. Ma'am, the next one. So under the ethical consideration and challenges of under the ethical consideration and challenges of AI/ML usage for credit risk prediction, the major problem is algorithmic biases that is coming in the picture, and also since it is individuals' data that is being used over here, there is a intrusion into privacy and confidentiality that is also coming into this particular problem. Then in the practical implications, there is a positive practical implication by indulging this AI and ML techniques. There is better credibility that can be used by the financial institutions to craft more personalized credit risk assessment methods, which can eliminate out the high risk profiles from the portfolio. Ma'am, the next slide. Ma'am, okay. Yeah. So as in conclusion, the management of retail credit default risk has undergone enormous changes after the introduction of AI and ML techniques. And these transformational changes has been surpassed by the demerits that it holds. However, there should be a special care that should be taken while in order to uphold the ethical standards, because the data that is being used are the personal data of the borrowers. So these are the things that needs to be taken into consideration. However, this model largely benefits the financial institutions to screen out the high risk profiles. And the next slides are references. That's it.
Any questions from the session, Chair?
No
No, I
questions
have
from
no
my
questions
side,
from
ma'am.
my side. Aruna ma'am.
No, no, ma'am. No questions from my side.
Thank you so
Okay.
Thank you so much.
Anyone else who is there who could not present and is now wanting to present?
Madam, can I
No.
begin with my slide once again?
Sorry, sir.
I want to show my slides. If you please,
Ma'am,
I have able to now send you the slide.
can you log out?
And ma'am, 1 minute. We'll have a snapshot for the participants and then you could leave.
Okay.
Just a second.
Wait. Okay. So I sincerely thank all our authors for their excellent presentations and contribution in this session. And thank you for being a part of the international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 9th versions and all the previous 8 versions of this conference. We'll be happy to have you in the 10th version in 2026. All the
Thank you so much.
presenter would be given their digital certificates via mail within 2 working days. And further, all the papers have already been forwarded to the Stringer. The publication would be live in 6 months.
Thank
Kindly
you.
cooperate with the team of ICTIS. I'd like to give the session chair a token of appreciation.
Thank you.
Yeah.
Thank you so much.
Thank you. Thank you so
Before the
much.
session, chair.
Thank you.
This is on behalf of Team ICTIS and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Now I request everyone to please switch on your cameras for a snapshot.
Just a second. It takes time. Just a second.
Okay, thank you everyone. Have a nice day.
Thank you.
Thank you.
everyone.
Thank you so much, ma'am.
Thank you so much.
Thank you.
Thank you, madam.